Cracking the code: how AI is learning to read human emotions. Have you ever wondered how artificial intelligence is able to detect human emotions? In this video, we'll explore the science behind emotion detection and how AI is learning to read human expressions. 1. The anatomy of emotions. Before we can understand how AI is able to detect emotions, we need to understand the basics of how emotions work. Emotions are complex psychological and physiological states that are typically characterized by subjective feelings, physiological changes, and expressive behaviors. Facial expressions are a primary way that emotions are communicated, with specific muscles in the face contracting and relaxing to produce various expressions that correspond to different emotions. These expressions are universal across cultures, and they are largely automatic, meaning that people cannot control them consciously. 2. The technology behind emotion detection. To detect emotions, AI systems use computer vision and machine learning techniques to analyze facial expressions and body language. Facial recognition software can identify different facial features and track their movements, while machine learning algorithms can analyze the patterns of movement and associate them with specific emotions. Natural language processing techniques can also be used to analyze verbal and written communication for emotional content. One common technique for emotion detection is called facial action coding, which involves analyzing specific facial muscle movements to identify corresponding emotions. Other techniques include using sensors to detect physiological changes such as heart rate and skin conductance, or analyzing voice intonation and patterns of speech. 3. The challenges of emotion detection. While AI emotion detection is a promising technology, there are several challenges that must be addressed to ensure its accuracy and reliability. One challenge is that emotional expression is highly variable and can be influenced by cultural, social, and individual factors. This means that emotion detection systems must be trained on large and diverse datasets to account for these variations. Another challenge is that emotion detection systems can be biased, particularly when they are trained on datasets that are not representative of the overall population. For example, if a dataset used to train a system is predominantly composed of one race or gender, the system may have difficulty detecting emotions in individuals from other races or genders. 4. Applications of emotion detection. Emotion detection has a wide range of potential applications in fields such as mental health, marketing, education, and law enforcement. In mental health, emotion detection systems can be used to diagnose and treat conditions such as depression and anxiety. In marketing, emotion detection can be used to gauge consumer responses to products and advertising. In education, emotion detection can be used to monitor student engagement and tailor instruction to their individual needs. In law enforcement, emotion detection can be used to identify potential threats and detect deception. However, there are also ethical concerns associated with the use of emotion detection. For example, using emotion detection in hiring or employment decisions could be seen as discriminatory. And using it in law enforcement raises concerns about privacy and civil liberties. Overall, the science behind emotion detection is complex and rapidly evolving. While there are still challenges to be addressed, the potential applications of emotion detection are vast. And the technology is likely to become more prevalent in our lives in the years to come.